Hello there. Today we are going to see an example of an application of the results that we have seen about integration so far. We are going to try to calculate the primitive of this rational function, 2x plus 4 divided by x squared plus 1. If we try to separate the numerator and the denominator, we can identify a little better the elements that are part of the integral. A general recommendation when it comes to resolving integrals is to never take things for granted, nor expect to automatically know the final result. Instead, we have to analyze the function carefully and see if any of the elements that appear are familiar or similar to things that we already know. For example, in this case, we could identify the denominator as x squared plus 1 as a certain function of x. If we consider it that way, we realize that the derivative of f would be 2x, and it turns out that 2x is multiplying in this case. Then that is very interesting. We have a function, 1 divided by a function, and multiplying we have what looks like a derivative. However, it is not exactly a derivative because it is not 2x plus 4, but 2x instead. What can we do here? Well, we are simply going to separate. Let's see the following steps. In the first step, we substitute the x squared plus 1 by f. Then we realize that, as we were saying, the 2x is the derivative, and only now what I can do is separate them, making use of the linearity. If I use the linearity, indeed, we would have on one hand the first derivative of the function of x divided by the function of x, and on the other hand 4 divided by the function of x. Well, the derivative of the function of x divided by the function of x is a pseudo-immediate logarithmic primitive. It is essentially the one obtained from the 1 divided by x. Generalizing here, the pseudo-immediate is the derivative of the function. Therefore, the first one will give us the Neperian logarithm of the absolute value of the function. The second of the integrals, 4 divided by the function of x, at first glance does not have its own derivative. Then, the advantage of using the function, in this case, is non-existent. Let's add said function back, 1 divided by x squared plus 1. One more time. After doing that, we quickly realize that that primitive is actually the immediate primitive of the arctangent, and therefore we can write the following expression. On the one hand, we can replace the function of x squared plus 1, and on the other, we have that the second integral is 4 times the arctangent. We have to notice the fact that the 4, which was in the numerator, has been able to be taken out of the integral, and once it is out of the integral, I will simply drag it. Let's not forget to add the c, which actually gives us the generality of the integral. If we do not put the c, what we would have calculated is a primitive, but we want all the possible primitives instead. We should mention one more potential change, even though it's not a major deal. When it comes to logarithms, we have this absolute value factor that can have a noticeable impact on the function. However, if the function within the absolute value is always a positive value, you can safely disregard the absolute value and leave it out. In this case, we could take it out, and we would end up having the natural logarithm of x squared plus 1 plus 4 times the arctangent plus c. The conclusion of this example basically is, whenever we have a function, we should not expect to know immediately its integral. We definitely should not expect to come up with a magic formula that automatically gives us the final result. But instead, we should analyze the function one step at a time and slowly but surely identify its different parts. If we manage to find a function and its derivative happens to be multiplying, that automatically gives us the idea that we can use a pseudo-immediate expression. And that, in most cases, will always reduce the complexity of the integral. That is all, students. Thanks for your attention.